2-3, the fundamental theorem of variation. All right, let's do a little bit of review of direct variation and inverse variation. Okay, let's begin with direct variation. Let's do an example. The area is equal to pi times the radius squared for any circle. Now you can see here that our constant of variation is pi, and our independent variable is r, and our dependent variable is a. So a varies directly as r squared. Alrighty, so let's take a look at a few values here that would result if we plugged in some different radii. If we put a radius of 1 in, we will get 1 squared, which is 1 times pi. We'll get 1 pi for the area. And if we put a radius of 2 in, we'll get 2 squared, which is 4. So we'll get 4 pi here. And if we put a radius of 3 in, we will get 3 squared, which is 9 pi. Notice I'm leaving them in exact form so that we can see any relationships perhaps a bit better. All right, direct variation. Now let's take a look at what's happening to these variables. All right, when we went from 1 to 2, we doubled. All right, so I'll put times 2. Now let's see what happened over here. Well, we went from 1 pi to 4 pi. That's not a double, that's a quadruple. So that is times 2 to the second. Now let's see what happens when we went from 1 to 3. That's a triple. We multiplied by 3. But to go from 1 pi to 9 pi is not times 3, it's times 9. So we did say before that our situation here on the area of a circle formula, a varies directly as the square of the radius. Okay? All right. Now, let's take a look at an example of an inverse function. All right, let's say you wanted to travel 100 miles and you wanted to figure out how long it would take at various speeds. Well, there is a way to do that. The time in hours that it will take to travel 100 miles is equal to 100 divided by your rate of speed, okay, however fast you're going. All right, so our constant of variation here would be the 100 miles. Independent variable would be the rate of speed, because that can change. And the amount of time is the dependent variable because it depends upon how fast you're going. All right, let's take a look at some possible values here that would work in this inverse function. Alrighty, remember, independent variable always goes first. Okay, rate of speed, let's keep these easy. Say you're going 10 miles per hour and you need to go 100 miles. That's going to take you 10 hours. If you're going 20 miles per hour, it's going to take you 5 hours. And if you're going 50 miles per hour, it's only going to take you 2. So as these increase, these are decreasing, but let's see how. All right, this is increasing by 2, so this doubled, the rate of speed doubled, and over here the amount of time was cut in half. So as we said before, the rate of speed here is inversely proportional to the time. So what we've got here, this is a half, this is an inverse of that, or the reciprocal. Let's see if it works here. Here we're going from 10 to 50 miles per hour. That is an increase of 5 times. It's 5 times bigger. And here to go from 10 to 2, the time is changing by the reciprocal of 5, which is 1/5. All right, let's sum this all up. We have the fundamental theorem of variation, and it has 2 parts. The direct variation part and the inverse variation part. Okay, let's start here. If y varies directly as x to the n, and we go ahead and we take the x and it's multiplied by a c, then y is going to be multiplied by c to the n. Because if we come up here to the x and we multiply it by a c, all right, that c is also going to be raised to the nth power. Okay, second part. If y varies inversely as x to the n, and x is multiplied by c, well, now remember, in an inverse, we're creating a division problem or a reciprocal or a fraction. All right, so we say then that y is divided by c to the n.